All right, we had a request to talk about some flux core wire setup on this machine. And so we're gonna go through a few different options here just to kind of let you know how I would go about doing this. So first off, we're on a TPS400. Previous video has been on a 320. This is water-cooled 400. So let's take a wander around here and see what we got, but it looks like they do. This one's a little bit different. We do have a gas mixer on here. So here we can select 100% argon, C2, 98.2, 9010, 7525, or 100% CO2. Just goes to a single outlet flow meter and then plugs in the machine. I just got a CO2 and an argon there, and really helps out to have a lot of adjustability, especially when you're talking different wires and stuff like what we got going on here. So we got three different wires. One is the Hobart XLR8, which is a T8 structural kind of a seismic wire. That would be a straight flux or like 100% flux, no gas needed on that one. I brought a spec sheet of an ESOB 710X, pretty common dual shield wire, so a gas shielded flux core. And then here we got a Hobart 777, which is a dominantly 7525 mix gas shielded flux core, and the spec sheets to go with that. So over here on the machine, what I kind of deal with to start with is just finding a process. Okay, so first we're going to go into our process. We're going to pick a filler metal, and so in this case we're going to change our material. And so I originally was on, I think, aluminum with this one. I still got a spool gun hooked up, but we went to a 71T1. And to talk also straight flux core, there is a flux core self-shielded setting as well, but for the interest of this one, we're going to go back to our 71T1, and we're an 045 wire. Different wires, different gases, so we could select between 100% CO2 or 7525. And in this case, we're going to go with 7525, so we can just match parameters with what we've got going with this wire here. So that's given me a range of options there. We're going to go back to welding. And now, since this is in kind of a synergic mode, which is giving us some input on what this needs to be, I can go over to a material thickness and bump this up. You know, let's say we're welding 1/4 inch plate. Okay, so on my 1/4 inch plate, that's giving a wire feed speed of 330 inches per minute, and it's setting us up with a voltage of 24.8. And so that is Fronius's pre-canned program for a gas shielded flux core. So the trouble is, not all gas shielded flux cores are the same. And so if we look on this here, we can see that on a 777, which is our 71T1 wire, a lot of different AWS stuff there, but for the simplicity of it, we'll just stick with 71T1. And here we have shielding gas, 100% carbon dioxide, 75 to 85% argon mix, and it gives us a flow rating. So this is DCEP. And as we go down here, we do have provisions for both 100% CO2 and 7525, but that gives you different values. So like a tensile strength, 100% CO2 is going to give us 82,500. It's going to give us 87,000 PSI tensile strength with 7525. And now here's where it ends up mattering, because on each different wire, they run a little differently. And so for the sake of 045, we're going to go along and look here and see that we do have a range for, we got all position, we got flat and horizontal. So all position means that it's going to run all position, right? You'll be able to run it out of position, vertical up, and it'll hold it. You get a little bit hot and you're going to get down into, you know, the 300 amp range for this 045. So as we go back over to our machine, and if I go spec sheet to machine, I'm going to see that if I have 24.8 volts on my machine side, I'm going to be in kind of the low to mid range. And so what Hobart is telling me is that I need to have 325 inches a minute in this range here. So I can select my inches per minute on here. So for me to go 325, it's going to put me at 24/7 on volts. And for me to go back over to my spec sheet, 24/7 would be on the high side. So it's kind of hard to hold everything there, but so 20 to 25 and 325. So I am on the maxed out end of what Hobart is suggesting to run on the Fronius settings. Now it's still in there, it's still going to work, but the thing to take away from this is when you do get into a gas shielded flux core, they're not all going to run the same volts. And so you got people that are saying, oh, I run 24 volts and 300 inches because that's how everything runs. That's false. And so you really do need to pay attention to both what gas you're using as well as what position you want to run it at. And so in this one says, this was determined by welding with 75-25 argon CO2 with a flow rate 35 to 50. So when welding using higher CO2 shielding gas mixtures within the recommended range or 100% CO2 shielding gas, increase voltage by approximately 1 to 3 volts. So the more CO2 you run, the colder it's going to run. So you need to add volts to make up that difference. And that's going to be common on any type of wire that you run. So when you go to the welding store and you pick up a box of wire and you see it is what you want, you know, it's 71T1, okay, great, that's what the print calls for. Now I go onto the website, print off the data sheet, and don't try to be the hero, because these geniuses have gone through and told you where this runs at and where it's going to meet all the parameters. And it also gives you packaging options, because some of these you might be out in the field, you know, 15 pounders are a nice option, 33 is, you know, they've gone up to barrels of stuff. The ESOB one is a little harder to read, but still same kind of a deal. Good to pull the spec sheet so you can see what kind of range you've got. And on their spec sheet, they do have a shielding gas C1. So for this is a 710X is the 100% CO2, 710XM is the mixed gas version of theirs. But they do still pull parameters for each one. So you have 100% CO2. These guys are a little more lax on their range. So if I was going to go on the low end of an 045, it's saying I could be between 130 amps and 205 amps. Well, between 23 and 26 volts. They do not give you the call out like the Hobart one does to pay attention to what volts you're running, because on the 75-20 mix, it gives you the exact same readout. So definitely got to have a little bit of knowledge going on the ESOB site, where the Hobart one is definitely put together a little bit nicer. On the straight flux, this XLR8 or Lincoln, you'll hear like NR232s, 233s, Core Shield 8s. All those 8s are a T8 wire, and in the place where we're at here, a lot of earthquakes, seismic area, T8 wire is going to be required, and that is giving you this same kind of spec. And it's telling you DCEN in this case, where we were DCEP before because we were gas shielded flux core, not a straight flux. Same set of ranges. 072 is much more common. This box I've got sitting here is a 16th, but again, giving you a range of what amps you'll come out to be, what volts, inches per minute, and then also contact tipped work distance makes a big difference there. And then again, back down here into your package quantities, 12 pounders, 15s, 20s, 33s, 50s, and that kind of stuff. So it is nice to use a preset wire and everything, and in most cases it is going to get you what you need, but it doesn't actually hurt to double check with what the wire manufacturer is, because they do end up having a pretty decent swing in volts sometimes. So anyways, hope that helps kind of unpack what some of these fluxes, gas shielded flux cores, and all the different stuff you need to get your job done. So good luck out there. Thanks for watching.